This is the mesh analysis. And another mesh analysis, that when we have this is just an example. This one is, I'm not solving this part. This is just telling you, when we have a mesh analysis, when we have like this, the current source is inside the mesh. So we can say that current source inside the mesh, so the current will be the same as minus I2 is minus 5 ampere. I2 is minus 5 amps. Understand this one. So basically this is just one small example I want to show you, that how we can solve when we have a current source rather than voltage source. Similarly, when we have the current source between two mesh networks, two loops, so this has become the super mesh. Like we have super mesh. In super mesh, what we do, we just omit the whole branch. We remove the in nodal analysis. We short and for short the line and short the source, and for the current. For the current, what we do, we just open the current source, and the opens the current source. Then this system becomes that system become like this: 6 ohm, 10 ohms, 4 ohms. Very easy. Then we have now very easy to solve it, and we apply the KCL. So we can apply KVL. We have minus 20, 6I1, 10I2, 4I2. Minus 20 plus 6I1 plus 10I2 plus 4I2 equal to 0. So we have this one, we solve this one, so it becomes equation 1, this one. When we have super mesh, first we apply KVL, then we have to apply KCL. So when we have to apply KCL, what is KCL? We have to apply the nodal analysis, and as we know that, so we can say that I2 is entering, I1 is here. We apply the nodal analysis here. So we apply I2 is moving here, I1 is moving here, and the 6 ampere is moving from upside. This is the node we select. We can select any node. We can select also the side. This is your choice. So for this one, I2 is entering, I1 is leaving, I6 is leaving. So when we have a entering on one side, leaving on the right other side, so we can say that I2 is equals to I1 plus 6. And when we have two equations, we can easily solve for I1 and I2. So this is the mesh analysis, super mesh analysis. Now we have another example, that if we have two sources, current sources, one is independent, one is dependent, but is inside the non-reference nodes. So one is non-reference node, one is non-reference node, and one is reference node. So what is this? How to solve this? So we can say that to solve this, first we open the current source. When you open the current source, you will see the network like this. So we will see the analysis like this, that we have 2I1, then we have 4I, because the current like this, I will make a drawing for here to make it easy. So it becomes this one. Currently I am solving this side. This is 6, this is 6 ohms, this is 2 ohms, 6 ohms, 2 ohms, this is 4 ohms, and this is 8 ohms. So we have the current is flowing from here. This one is I1, so this is I1, so 2I1, this is I2, so, and this is I3. So you can have 2I1, I3, 4I3. But the only thing that when we calculate the 8 ohms also on the right side, we have this network, which is I4. So the 8 ohm is not dependent on I3 only, it's also dependent on I4. I say that we will take a direction of I3. So we have I3 minus I4 into 8. So we have I3 minus I4 into 8. So we have this equation. So we have 4 variables now, 4 loops, 4 variables. So we have I1, I2, I3 and I4. The first step, we take the loop. Another loop, we have another mesh here. So we have, this is 10 volts. We can say that the voltage or current across this becomes, I told you as well, this is I4 minus I3 into 8, and this one is I4 into 2. So this one is 10, this one 8, I4 minus I3, this is 2 into I4, so equal to 0. So we have the equation, we will solve the equation, so it becomes I3 and I4. So this is equation 2. So we already, first we try to solve using the, first we try to use the loops, then we will go for the nodal analysis. So now we apply the nodal analysis. So here we can see at the P node, we know that I2 is entering, I1 and I5M is leaving, so it becomes I1 plus 5 equal to I2. So we can say that I2 is equals to I1 plus 5, one node. Another node we apply at node Q. So this is entering, this is leaving, this is entering. So 3 I naught plus I3 is equals to I2. So you can also write I2 is equals to I3 plus 3 I naught. And what is I naught? What is I naught? And I naught is, here we can see the I naught is this one, and I naught is minus I4. So we can put it also like this. I2 is equals to I3 plus 3 minus I4. So we have I2 equal to I3 minus 3 I4. So we have the another equation 3, we have another equation 4. How many variables we have? We have 4 variables, so we required 4 equations. And we have 4 equations. We use the Cramer rule and we calculate the I1, I2, I3 and I4. So this is the way we can calculate the I1, I2, I3 and I4. So I just give you the matrix for easiness. We have 1, we have 3, we have 6, we have minus 4. Then we have another equation, we have 0, we have 0, we have minus 4, we have 5, then we have 1, we can say minus 1, 1, 0, 0. Then we have 1, 0, 1, minus 1, and plus 3, and we have I3, I4 is equals to, for one equation we have 0, second equation we have minus 5, third equation we have positive 5, fourth equation we have, for the fourth equation we already have 0. So this is the Cramer matrix, and you use the Cramer rule to solve this. So you will get this I1, I2, I3 and I4.